Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmad Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra Unit 2 lesson 2. The lesson is called Operations on the Algebraic Fractions. In this lesson, inshallah, we are going to study the meaning of the fractional function, and we are going to study the concept of the domain of the algebraic fractional function, and also we are going to study how can we prove that two fractions are equal, and also we are going to study how can we add, we can subtract, we can multiply and divide algebraic fractional functions. Let's start the lesson. First, we are going to study the meaning of the algebraic fractional function. Okay, in the first term we have studied the polynomial function. Okay, and we said that the polynomial function is a function that written in form in terms of x, in which the denominator is it doesn't include x and it doesn't include also root of x. Okay, so what is the fractional function? From its name, it is a function written as a fractional form like this. Okay, for example, f of x equal x minus 3 over x plus 2. This is a fractional function because it is a fraction. It is a fraction formed from x up and x down like this. This is a fractional function. Another example like this, n of x equals 3 over x minus 4. This is a fractional function because we have x here in the denominator. Okay, now we are going to study or to remember what the meaning of the domain. The domain of the fractional function. General, what is the meaning of the domain? The domain means all the possible values of x, or all the possible values of the unknown. The unknown here is x. Okay, what are the possible values of the unknown? In the first example, I can use all the real numbers except one number. What is this number? This number is negative 2. Why? Because here, if I put a negative 2 in place of x, this will be negative 2 plus 2 equals 0. So it will be undefined, so it will be error. Okay, so I can use all the real numbers except negative 2. And here also, I can use all the real numbers except 4, because 4 minus 4 is 0, and this gives me error. So the domain here is all the real numbers except the number 4. Now let's study an example for the how can we find the domain of the function. In this example, he asked me determine the domain of the following algebraic fractional function that are defined by the following rule. Okay, and then find n of 0, n of negative 1, and n of 2. Okay, first, the function here is x plus 5 over x power of 3 minus 8. Okay, now the main object here is the denominator. I need the denominator, so I'm going to do what? So I'm going to find the zeros of the denominator, the values which makes the denominator equal 0. Okay, like this, x power of 3 minus 8 equals 0. To solve this equation, I'm going to send 8 to the right side. It will be 8, so x power of 3 equals 8. Okay, now I have x power of 3, so I'm going to take the cubic root of the number 8 like this. Now the cubic root of the number 8 is 2, so x equal 2. So if I used x equal 2 in the denominator will be 0, so it will be meaningless. So the domain here is what? I can use all the real numbers except the number 2. So the domain here is r difference 2, or r minus 2, or r without 2. Okay, now the second required, he asked me to find n of 0, n of negative 1, n of 2. n of 0, I'm going to put 0 instead of x, in place of x. So it will be 0 plus 5 and 0 power of 3 minus 8 like this. So it will be negative 5 over 8. Another one, I need n of negative 1. So I'm going to do what? I'm going to write here negative 1 in place of x, and write here also negative 1 in place of x. So it will be negative 1 plus 5 over negative 1 power of 3 minus 8, so it will be negative 4 over 9. Now n of 2. N of 2 means I'm going to put 2 instead of x and x. But I see here that the domain is R, all the real numbers without 2. So I can't use the number 2. So n of 2 here is meaningless or undefined, because I can't use 2 in place of x, because it will give me an error, okay, like this, or it is outside the domain, so it is meaningless or undefined. Okay, now I have another example. Prove that n1 equal n2. n1 a fraction and n2 another fraction. I need to prove that the two fractions are equal. Okay, to prove that the two fractions are equal, so I'm going to divide the page in two halves. Okay, in the first half I'm going to simplify the first fraction and find its domain, and also in the second one I'm going to simplify the second fraction and I'm going to find its domain. Okay, like this. Here the first one, I have x power of 2 minus x. To factorize this one, I'm going to take x as a common factor, because x here is repeated, so I'm going to write the fraction like this and the x outside bracket, and here x power of 2 divided by x equal x, and the negative x divided by x equal negative 1. Okay, in the denominator, I have now x power of 3 minus 2x power of 2. So I'm going to do what? I'm going to take x power of 2 as a common factor. Why x power of 2? Because in the common factor, I'm going to take the smallest power. Here x power of 3 and x power of 2. The smaller power here is x power of 2, so I'm going to take x power of 2 outside, like this. X power of 3 divided x power of 2 equal x. And negative 2x power of 2 divided by x power of 2. X power of 2 and x power of 2 cancelled, and I'm going to write down negative 2 like this. Here, the second step, I'm going to identify the domain. Okay, the domain here is R, okay, minus the zeros of the denominator. What is the zeros of the denominator? The zeros of the first number, x power of 2, is 0, okay, and the 0 of this bracket is 2. So the domain here is R minus 0 and 2, like this. Okay, now I'm going to cancel the common factor up and down. What does it mean? Here I have x up and x power of 2 down. I'm going to cancel x with x, so the remainder will be x minus 1 here, and down x times x minus 2 here. This is the first fraction. The second fraction, okay, now I have trinomial and there isn't any common factor, so I'm going to factorize this trinomial by open two brackets like this. I'm going to distribute x power of 2 here and here, x and x. I'm going to look to the third sign. The third sign is positive, so I'm going to do what? Positive, so I'm going to repeat the middle sign in both brackets. So I'm going to write negative here and the negative here, like this. Here 2 equal what? 2 equal 2 times 1, so I'm going to write 2 in the first one and 1 in the second one, or I can reverse them, okay, like this, 1 and 2. In the second one, I have here trinomial, but I have now a common factor. Why? Because here I have x in all the factors, so I can identify the smallest x with them, which is x power 1. So I'm going to write x power 1 like this outside. Now I'm going to divide x power 3 divided by x, which is equal x power 2, negative 4. Okay, x power of 2 over x equal x, and 4x divided by x equal 4. Okay, like this. Now I'm going to do what? I'm going to factorize the denominator, because there is another trinomial. Okay, the numerator without change. I'm going to write down x, and this trinomial will be two brackets like this. I'm going to distribute x power of 2, x and x. Okay. Here I have positive sign, the positive sign, so I'm going to repeat the middle sign, here negative and negative. Now 4 equal 1 times 4 or 2 times 2. Because the middle term is 4, so I need the sum of the two factors equal 4. So I'm going to choose 2 times 2 like this. Now the next step, I'm going to write down the domain. What is the domain in that case? The domain is the zeros of the denominator, so it will be r minus 0 and positive 2 and another positive 2. Okay, so I can't repeat the number 2 twice, so I'm going to write 2 one time only. Here, by looking carefully to the two fractions, but before, I'm going to cancel the common factors. Here I have x minus 2 and the x minus 2 cancelled together. So finally I have x minus 1 over x minus x times x minus 2. By looking carefully, I have the same domain. Here I have r minus 2 and here also I have r minus 0 and 2. And here I have x minus 1 over x times x minus 2, and also we have here the same fraction, so I can say that n1 equal to n2. Now let's study how can we add or subtract algebraic fractions. Okay, to add algebraic fraction, I'm going to explain in the following example like this. Here I have fraction, okay, x over x power of 2 minus x plus another fraction x plus 1 over x power of 2 minus 1. To add these two fractions, first I'm going to factorize. Number 2, I'm going to take out the domain. Number 3, I'm going to add. Okay, the first step, I have here x. Okay, so x written without change. I have x power of 2 minus x, so I'm going to take x as a common factor. It will be x times x minus 1 plus x plus 1 written without change. X power of 2 minus 1, this is difference between two squares. I'm going to open two brackets. So I'm going to write x and x, negative 1 and positive 1. And 1 here comes from the square root of 1. So the first step, I have factorized the four terms of this expression. This is number 1. Number 2, I'm going to take out the domain. The domain here r minus the zeros of the denominator. R minus 0, negative 1, positive 1, negative 1, and another positive 1. So I write down here r minus 0, negative 1, and 1. Okay, now I'm going to cancel the common factors. Here I have x and x, I'm going to cancel them. Here I have x power 1 plus 1 and x plus 1, I'm going to cancel them. So the first fraction will be x over x minus 1 plus 1 over x minus 1. Because we have here a common denominator, so I write down the same denominator and add the numerator. So it will be 2 over x minus 1. 2 comes from 2, 1 plus 1 equal 2. Okay, and the denominator is x minus 1. Okay, now let's study how can we multiply two algebraic fractions. Okay, in this example, the first step to multiply the two expressions or the two fractions, I'm going to factorize the four terms. Okay, x plus 2 written without change. Okay, x power of 2 minus 4, this is difference between two squares. It will be x minus 2 and x plus 2 times. Here I have 2 and 4, so I'm going to take 2 as a common factor. So it will be 2 and between brackets x minus 2. Here x minus 3 written without change. Okay, the domain here is what? The domain is r minus positive 2, negative 2, and positive 3. Okay, again 2 and negative 2 and positive 3. Finally, I'm going to cancel the common factors. Here I have x plus 2 and the x plus 2, and I have also x minus 2 and the x minus 2. Okay, x minus 2 and x minus 2 like this. Finally, I have now 2 over x minus 3. This is the simplest form of this example, and this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullah wa barakatuh. Mr. Ahmed Mahmoud was